Morning, viewers. This is Kasturi Dev. Today, I'm going to start with the question answer discussion of this chapter, Motion in One Dimension chapter. So, in my last video, I've completed some ICSE specimen questions, but then now I will start with some back questions which are present in the book and some other books also. So, I will discuss them. Okay. So let me start with, before that, I will request you to please to subscribe my channel and ring the notification bell so that you can get to know when a new video is uploaded. Okay, and if you are liking the video, press the like button, share with your friends and colleagues so that they can also be benefited from these videos. And also do meditate before starting routine. Okay. So for meditation, let us meditate for 1 minute and then we will start with the discussion. So first, for that, please concentrate on a point of light. You can concentrate on a bulb also, lighted bulb. Okay, use that as a point of light and do concentrate on it. Think that the rays which are coming from the light are giving you energy. Your whole body is getting energized. Each and every part of the body is becoming happy. And whatever work you want to do, you're doing it enthusiastically, happily. Interestingly, you can do it. And also, you're becoming successful in your body. You are doing. You're feeling really happy. You do. This you can meditate for 1 minute after each work you complete. Start your new work. So let's stop here and get back to our discussion. Okay. So first question which we will discuss today is differentiate between the scalar and the vector quantities, giving two examples of which. One is scalar, that is scalar and vector in the tabular form I've discussed. So first is it has only the magnitude and no direction in case of scalar. But in vector, it has both magnitude and direction. Okay. Scalar only one dimensional, vector is multi-dimensional. Now scalar quantities change with the change in magnitude, but vector quantities does changes with both change in magnitude and direction. Okay. In scalar, if the magnitude changes, then it changes, then the quantity changes. But in vector, both the magnitude or the direction changes, then the quantity changes. Okay. Then a scalar quantity can be added, subtracted, or multiplied or divided by simple arithmetic methods. But in case of vectors, they can be added, subtracted, or multiplied, followed a different algebra. Okay. Next is they are symbolically written in an English letter. Scalar quantity can be written symbolically in an English letter, whereas vector is symbolically written by their English letter with an arrow on the top of the letter. Okay. Then example of scalar quantities is mass, speed, vector is force, velocity. Next, we come to the second question. What is a body? When is a body said to be at rest? When, if a body does not change its position with respect to its surroundings. With respect to its surroundings, this is very important. If you have to write with respect to its surroundings. If the body is not changing its position, then the body is said to be at rest. Okay. When is a body said to be in motion? Again, with respect to its surroundings or observer, if the body changes its position with time, then the body is said to be in motion. Okay. What do you mean by motion in one dimension? It means that the motion that is along a straight line. It's moving along a straight line or motion in one particular direction, then it is one-dimensional motion. Okay. The next question is define displacement, state its unit. So displacement is defined to be the change in position of an object. It is a vector, meaning it has a direction as well as magnitude. Okay, so vector means it has to be a direction along with the magnitude. Okay, so displacement it is the change in position of an object, but it is a vector quantity as it has both direction and magnitude, and is represented visually as an arrow that points from the initial position to the final position. As a pointer, arrow should be in that direction. SI unit of displacement is meter and CGS unit is centimeter. Okay. Next, we come to the difference between the distance and displacement. Okay. Now, distance is the complete length of the path between any 2 points, whereas displacement is the direct length between any 2 points, which when measured along the minimum path between them, the shortest distance, that is the displacement. Okay. So, now distance is denoted by small d, whereas displacement is denoted by small s. Now, during calculation, direction is not considered in case of distance, but in case of displacement, during calculation, direction is always taken into consideration. That's why distance is a scalar quantity as it has only magnitude, no direction, but displacement is a vector quantity as it depends on both the magnitude as well as direction. Okay. Now, distance gives detailed route information that is followed while traveling from one point to the other, whereas displacement does not give the detailed route information as it refers to the shortest path. That's why it does not give the detailed route information. Now, distance is not indicated with an arrow, whereas displacement is always indicated by an arrow. Now, distance can be measured along a non-straight path also, but here in displacement, it can only be measured along a straight path only. Okay, it depends upon the path, that is distance depends upon the path, whereas displacement does not depend upon the path, but depend upon the initial and the final position. Okay. Next question is, can displacement be zero even if the distance is not zero? Give one example to explain your answer. Yes, it can be possible that displacement can be zero, but even if the distance is not zero. For example, if a body is having a circular motion, that is, it is moving on a circular path, okay, where displacement is zero because it's continuously changing its direction, okay, but in its distance is not zero because it is covering the whole circular path. Okay. Now, define velocity, state its unit. Okay, so velocity is defined as the rate of change of distance of a body with respect to time. Rate of change of distance of a body with respect to time, its SI unit is meter per second. Now, define speed. What is its SI unit? Speed is defined as rate of change of distance with time. In case of velocity, it is rate of change of displacement with time. Whereas in case of speed, it is rate of change of distance with time. It has the dimension of a distance by time. SI unit is also meter per second. Okay. So what is the difference between speed and velocity? Velocity has direction, whereas speed does not have a direction. It does not depend on direction of the moving object. Now, distinguish between speed and velocity is a major difference. Okay. Now, what are the other differences which are there? So, velocity, it is the rate at which an object changes its position in a certain direction. Direction has to be specified. Whereas in speed, rate of change of an object covers a certain distance without any specified direction. Now, Velocity is a vector quantity because it has a direction, it has a specified direction. Speed is a scalar quantity because it does not depend on the direction. Velocity can be zero, negative or positive. Speed can never be negative or zero. Okay, velocity changes with the change in direction of the object, and so the object must follow one direction. But in case of speed, it does not change with the change in direction of the object. Now, velocity object, in case of velocity, object may have different velocities, but always at the same speed. Okay, but in case of speed, may or may not be equal to velocity. Now, velocity is equal to displacement by time, speed is equal to distance by time. Next is, what is instantaneous speed same? Sorry, when is instantaneous speed the same as that of the average speed? If a body moves with uniform speed, if the body is moving with uniform speed throughout at any point, throughout the journey, the body is moving with uniform speed. At any point of time, the instantaneous speed is same as the average speed. Okay. Now we will distinguish between uniform velocity and variable velocity. Okay. So uniform velocity is if the displacement covered by the body in equal intervals of time are same, then its velocity is uniform. So the displacement which is covered by the body at equal intervals of time is the same. In case of variable velocity, the displacement covered by the body in equal intervals of time are not equal, not same, then its velocity is variable velocity. Uniform velocity is no change in magnitude or direction. There's no change in magnitude or direction, whereas in variable velocity, there is change in magnitude or direction or both. Uniform velocity, here acceleration is zero, whereas in variable velocity, acceleration is not zero. Now distinguish between average speed and average velocity. Average speed determines how fast or slow a particular object is traveling, whereas average velocity defines the rate of change of displacement. Okay, so average speed shows how fast or how slow a particular object is moving, whereas average velocity determines the rate of change of displacement. Excuse me, average velocity, average speed does not have any specific direction. Whereas average velocity does have a specific direction. Average speed is a scalar quantity, average velocity is a vector quantity. Formula is total distance by total time spent, whereas in case of average velocity, it's a total displacement by total time taken. In average speed, while traveling in circular path, average speed can never be zero. But in case of average velocity, while traveling in a circular path, average velocity can be zero. Because it's continuously changing its position, it's coming to the same point, same original point. Okay, starting point. That's why this displacement can become zero, and therefore the average velocity can become zero. Now, give an example of motion of a body which is moving with a constant speed but with a variable velocity. So, a diagram represents such a motion. The motion of a body in a circular path with uniform speed has a variable velocity because it's circular path. The direction of motion of the body continuously changes with time. Okay? Direction of the motion of the body continuously changes with time. Now, see, this is the circular motion. It changes continuously. It's moving from A to B, it changes its direction. Then from B to C, it again changes its direction. From C to D, it also again changes its direction. Now, define acceleration, state its SI limit. It is the rate of, what is acceleration? It's the rate of change of velocity with time. It can also be defined as the increase in velocity per second. SI unit is meter per second squared. Distinguish between acceleration and retardation. Acceleration is if the velocity of a body increases with time, it's called acceleration. Whereas retardation, the velocity of the body decreases with time, then it is called retardation. Okay. Now, acceleration, as it is increase of velocity in velocity, as it is an increase in velocity per second, so it's positive acceleration. That is in retardation, as it is decreasing velocity per second, so retardation will be negative acceleration. Okay. Now they differentiate between uniform acceleration and variable acceleration. Uniform or constant acceleration. Uniform acceleration can also be called as constant acceleration. Okay. Now, which is equal to equal change in velocity in equal intervals of time. Equal change in velocity in equal intervals of time. Whereas variable acceleration and non-uniform acceleration is also known as non-uniform acceleration, which is equal to unequal change in velocity in equal intervals of time. Okay. For example, the motion of a body under gravity. Example, free fall of a body. Okay, so there will be equal change in equal intervals of time. Whereas the variable acceleration, that is the motion of a vehicle on a circular and hilly road. What is meant by the term retardation? Means its SI unit. Retardation is the decrease in velocity per second. Its SI unit is meter per second. Define the term acceleration due to gravity. State its average value. When a body falls freely under gravity, the acceleration produced in the body due to the Earth's gravitational pull is known as acceleration due to gravity. So when the body is falling from the top, okay, and it's falling freely, okay, its body is falling freely. The acceleration which the body is gaining, the falling body is gaining, that is due to the Earth's gravitational pull. And that is why it is known as acceleration due to gravity. It's represented by small g. The average velocity of g is 9.8 meter per second square. Okay. Now we come to the 20th question, that is choose the correct answer. A body, when projected up with an initial velocity u, goes to the maximum height h in time t, and then comes back at the point of projection. Okay, so it has been projected up with an initial velocity of u, maximum height it reaches at h in time t, and then it comes back to the point of projection. The correct statement is the average velocity is 2h by t, acceleration is 0, final velocity reaching the point of projection is 2u, and displacement is 0. So the answer will be initial velocity is given as u meter per second, acceleration due to gravity is g as known as earlier. Then time is t second, height obtained is h meter. The average velocity will be total distance by total time taken. So what is total distance? h going up and again coming down. So 2h. And time t seconds taking to go up and again t second to come down. So 2t. That means h by t. Okay. Then acceleration as it is coming down, so it will be minus g, that is retardation. And acceleration equation of motion in option 3, that is b squared is equal to u squared minus 2gs. S is displacement, shear initial and final. Since initial and final. Now, points are same. Sorry, since where S is the displacement, its initial and final position are the same. And so points are same, so the displacement is 0. Therefore, final velocity will be equal to 0. Why? Because displacement is 0. Okay. So we can say that option 4 is correct. Displacement is 0. Okay. So I think I'll stop here. I'll continue with the rest of the question answers in our next video. Please go through this. If you have any doubt, please do let me know. Please do write in the comment box. And if you are liking the video, press the like button and share with your friends so they can also be benefited from these videos. And please do ring the notification bell because that will indicate you as soon as new video is uploaded. And please do meditate before starting your day. Okay. So thank you for watching and have a good day.